Okay, Lissajous pattern. This is the last subtopic for this chapter. Lissajous pattern. One of the quickest methods of determining frequency is by using Lissajous patterns. Lissajous pattern can be viewed in oscilloscope. It results when two sine waves are applied simultaneously to the vertical and horizontal plates of CRO oscilloscope. Okay, when there are two sine waves, we can analyze the phase shift and the frequency of the two signals by using Lissajous pattern. The shapes of the Lissajous pattern depends on the frequency and phase relationship of the two sine waves. Class, can you see my screen?
Can, Doctor?
Yeah. Okay, the shapes of the Lissajous pattern depends on the frequency and phase relationship of the two sine waves. Okay, you can watch the YouTube video here to clearly observe the Lissajous pattern on oscilloscope. Okay, so Lissajous patterns are generated by XY mode on time division node. Okay, so this is time per division node on oscilloscope. So you can see here the setting of time per division, 0.5 second, 0.2 second, 0.1 second, and then here you have 50 millisecond, 10 millisecond, 2, and so on. And we have button XY mode here. So when we turn this node to XY mode, we can observe, we can see the Lissajous pattern on the screen. Two sine waves of the same frequency and amplitude may produce a line, an ellipse or a circle depending on the phase difference. Lissajous figures depends on, so it depends on amplitude, phase difference between the two sine wave, and also ratio of frequency of the two sine wave, meaning that depends on frequency of both sine wave. Okay, so we go to the phase measurement of Lissajous pattern. So Lissajous pattern can analyze, can measure phase shifts between two sine wave, and also can measure frequency of the two signals. Okay, an oscilloscope can be used to find the phase angle between the two sinusoidal quantities of the same frequency and amplitude. Okay, the phase angle is determined by this formula. Sin theta is equal to y1 over y2. Y1 is so theta here is phase angle or phase shifts between the two sine wave. Y1 is the y-axis intercept, and y2 is the maximum vertical deflection. Okay, so the y-axis intercept divided with the maximum deflection. Okay, the peak value at the y deflection, vertical deflection. Okay. For example, determine the phase angle if y1 is equal to 1.8 and y2 is equal to 2.3 cm. So we know that y1 here is the y-axis intercept, and y2 here is the maximum deflection, maximum value at vertical deflection. Okay, so sin theta is equal to 1.8 divided with 2.3, we get 0.783, so theta is equal to 51.54. Determine Okay, so you can try this. Determine the phase angle with the ratio of y2 to y1 is 1.25. You can try, compare your answer with your friends. Determine y1 if the phase angle is 0 and y2 is 4 cm. Okay, so you should watch the video that I give the link just now to understand Lissajous pattern. Okay, so this is the example, some examples of Lissajous pattern. Okay, so let's say we have two axes. Okay, x-axis and y-axis. X-axis and y-axis. Let's say x-axis is represented by channel 1 and y-axis channel 2. So if the frequency for channel 1 is 1 Hz and channel 2 is 1 Hz, okay, so and the phase shift is equal to 0, meaning that two sine wave is in phase. Okay, so if you can see this sine wave, actually there are two sine wave here. Okay, but the sine wave is redundant because of 0 phase shift. Okay, so Lissajous pattern will be diagonal movement like this, but it is non-stationary, meaning that it's moving. Okay, so this dot will move in diagonal movement up and down like this. Okay, x position move back and forth in a second. Okay, so x position is 1 Hz, meaning that in 1 second it will move back and forth. Y position as well, 1 Hz. Okay, so it will move up and down in 1 second. Okay, and then if x-axis is 1 kilohertz and y-axis in 1 Hz, okay, the phase shift is still 0 degree. Okay, meaning that if we observe the sinusoidal waveform, so the two waveform will be like this. It is redundant. Okay, but if we want to see the Lissajous pattern, we turn the time division knob to XY mode. Okay, x position move back and 4,000 times in second. Okay, because of 1 kilohertz, so x position move back and forth 1,000 in second. So because of 1,000 in a second, we can see the line. Okay, we can see the line on the screen. Okay, rather than 1 Hz. Okay, for 1 Hz we can see the dots. Okay, moving in diagonal movement. Because of 1K, the movement is very fast. It is 1,000 in a second. So we see the line. Okay, the line. Y position move up and down in 1 second. Okay, because of 1 Hz in y-axis. Okay, so y position move up and down in 1 second. So actually this line will appear up and down. Okay, after this we will watch the YouTube video. Okay, now let's say the frequency for x-axis is 1K. Okay, and the frequency for y-axis is 1K as well. So okay, and the phase shift is equal to 0 again. If we compare this with the first, okay, so the diagonal line will appear on the screen, but okay, actually it is the diagonal line is moving, but we cannot see the movement because of 1 kilohertz in a second, 1 kilohertz in a second. So we only see the line appear on the screen. Okay. Okay. Now let's say the frequency on x-axis is 1K, y-axis is 1K, but the phase shift is 180. Okay. Class, can you understand so far? Okay, please observe first. After this, we watch the video, but I think the sound is not clear because I play the video from YouTube. Okay, even though I maximize the volume, I think you cannot hear to the voice clearly. Okay, but later you should you should watch the video. Okay, so if the phase shifts between the two waveform is 180. So one sine wave will be at positive, okay, and the other one will be negative. Okay, it will opposite direction. Okay, because of 180 phase shift. Okay, so the Lissajous pattern will be like this. Okay, it is opposite of this because of 180. Okay, since the frequency for both position for both axis is 1K, so 1000 movement in a second for both x and y position. So we can see the diagonal line on the screen. Okay. Okay, now let's say, okay, so this is these are the example. Let's say x-axis is 1 Hertz, y-axis is 1 Hertz, but the phase shift is 90 degree. Okay, meaning that the second waveform lead or lag by 90 degree. Okay. So because of small frequency, we can see the dot moving around in a circle. Okay, actually this dot is moving around in a circle, traversing around in a circle in a slow motion because of 1 Hertz. Okay, only one cycle in a second. Okay, but if both frequency is 1K, so traversing around in a circle 1,000 a time, 1,000 second, 1,000 times in a second. So because it is too fast, then we found we can see a circle, static circle on the screen. Okay, and then if we vary the phase shift to 80, 70, and so on, the circle will be like this. Okay, so imagine that the degree is equal to 70, 90, 70, 60, 50, and so on. So it will and lastly go to 0 degree. So this circle will be a diagonal line. Okay, so let's refresh. This is for negative slope. This one is for positive slope. Okay, 0 degree. This is diagonal pattern. Okay, this one is 180. So negative slope. 90 degree, we will get a circle. Okay, so if we vary the phase shift to 80, 70, and so on, so this circle will be apa ni, narrow, become narrow and narrow. Okay, until diagonal line is formed. Okay, can understand so far?
Kenalan.
Boleh?
Taking on.
Can you understand or not? Okay, class. Let's watch this video.
Kick it off and it goes across the screen.
Class, can you hear the voice of this YouTube channel, YouTube video?
Very little.
I can very little because of I play from the YouTube video. Okay, but it's okay. I just want to show the pattern, okay, of Lissajous pattern. Okay, so we set at XY mode. Okay, 1 kilohertz for both. Okay, actually there are two signals, but because of in phase, the phase shift is equal to 0, so it is redundant. Okay, both are 1 hertz. Okay, so both signal 1 hertz.
And they're the same frequencies.
Okay. Channel 1 for X position 1 kilohertz. One hertz for Y position, so that's why it moves slowly. One cycle for 1 cycle in a second. Okay, channel 1, 1 Hz and channel 1 Hz as well. Because of 1 Hz. Okay, if 1 kilohertz okay, really fast in 1 kilo in a second. 80, 70, 60 until 0 degree. Okay, until 90. Okay, now one channel is 1 kilohertz and another channel is 2 kilohertz. Just the phase. Okay, 3 kilohertz. Another one is 1 kilohertz. Okay, class. Okay, so okay, the next measurement for Lissajous pattern is for frequency measurement. So okay, let's say we set channel 1 X position to 2 kilohertz and channel 2 XY position to 1 kilohertz. And phase shift is equal to 0 now. X position will move twice as Y position. So that's why we will get two loops, okay, at X position. And when the phase shift is vary, we can see this pattern, okay. Okay, so next, so one of the objective in Lissajous pattern is to determine frequency by comparing it with the known frequency. The unknown frequency is presented to the vertical plate and the known frequency is presented to the horizontal plate. Okay, so FV is for vertical, FH is for horizontal. Okay, the more complex the ratio between horizontal and vertical frequencies, the more complex the Lissajous pattern. Okay, for example, the ratio of horizontal and vertical here is 3 to 1. Okay. Here, the ratio of horizontal to vertical is 3. Okay, because of 3 loop here with 2. Okay, 1 and 2. Class, can understand? Can you understand?
Gonna take time.
Confused?
Yes, I'm gonna take a bit time.
Okay, it's okay. Okay, to determine the frequency from any Lissajous figure, use the formula. Okay, so we use the formula. Vertical frequency is equal to number of horizontal loops divided with number of vertical loops multiplied with horizontal frequency, or Fy over Fx is equal to number of horizontal loops over number of vertical loops. Okay, this is for integral frequency, this is for non-integral. The formula is the same. Okay, Fy over Fx, horizontal loops divided with vertical loops. Okay. Okay. These are Lissajous pattern for integral frequency. Integral meaning that Fv and Fh are in an integral ratio, even though it is even or odd. Okay. Non-integral frequencies meaning that okay, we can see ada nak okay, this is non-integral pattern, this is integral pattern. Okay, so how to determine the equation for the pattern. Okay, so this one is Fv equal to Fh, this one is okay, so you just count how many loop on vertical. Okay, only one, is it? So 1 Fv is equal to, and we have 2 loops on horizontal, so 2 Fh. Okay, this one we have 3 loops on horizontal, so put 3 Fh, and we have only 1 on vertical, so put 1 Fv. Okay, so this one is Fv is equal to 4 Fh. This one Fv is equal to 5 Fh. This one Fv, okay, the vertical is 2 loops, so you can write like this: 2 Fv is equal to Fh. Okay, 2 Fv is equal to Fh. Okay. This one we have 3 loops on vertical axis, so 3 Fv is equal to 1 Fh. Okay. This one so this one 4, so 4 Fv equal to 1 Fh. So 5 Fv equal to 1 Fh. This one 2 Fv. Okay, we have 2 loops on vertical. Okay, 1 and 2. So 2 Fv equal to 1, 2, 3, 3 Fh. Okay. This one we have 1 and 2 on vertical. Okay, so horizontal we have 2 horizontal, so 1 and 2, so 2 have Fh equal to 1, 2, 3 Fv. Okay, this one we have 2 Fv. Okay, 1 and 2 equal to 5 Fh. 1, 2, 3, 4, 5. This one 5 Fv. Okay, on vertical we have 1, 2, 3, 4, 5 loops. Okay, equal to for horizontal we have 1 and 2 loops equal to 2 Fv. Okay, any question? Any question? Can understand?
Clear, doctor.
Clear? Okay, two sine wave of equal phase and magnitude are applied to the input terminals of an oscilloscope operating in the SY mode. SY mode for Lissajous pattern. If the signal applied to the horizontal input is twice the frequency of the vertical input, sketch Lissajous pattern. Okay, so horizontal input is twice, okay, of the vertical. FH is equal to 2 FV. Okay, horizontal input is equal to twice vertical, twice of vertical. So the Lissajous pattern will be like this. Only one loop on horizontal, okay, and two loops on vertical, 1 and 2. Okay, so you can just the question is to sketch the Lissajous waveform, so you can sketch like this. Okay, 8 shape. Two sine wave of equal phase and amplitude are applied to the input terminal of an oscilloscope operating in the XY mode. If the signal applied to the vertical input, okay, vertical input is equal to twice the frequency of horizontal, twice the horizontal. Sketch the Lissajous pattern waveform. So FV is 1. Okay, on vertical we have only 1, but on horizontal we have 2. So 1 and 2. Okay, so it will be like this. Okay. Digital storage oscilloscope, or DSO for short, is now the preferred type for most industrial applications, although simple analog CRO, okay, that we have learned previously, are still used by hobbyists. It replaced the unreliable storage method used in analog storage scopes with digital memory, which can store data as long as required without degradation. It also allows complex processing of the signal by high-speed digital signal processing circuits. The vertical input, instead of deriving the vertical amplifier, is digitized by an analog to digital converter. Okay, the data set is processed and then sent to the display, which in early DSO was a cathode ray tube, but it's now more likely to be an LCD flat panel. Okay, this is the newest digital storage oscilloscope. DSO with color LCD displays are common. This is DSO. The data set can be sent over a LAN or one for processing, or the scope's own signal software can extract many useful time domains such as time rise, pulse width, amplitude, and so on, frequency, spectral histogram, statistic, and so on. Okay, meaningful to engineers in specialized fields such as telecommunication and so on. Okay, so we are end of chapter 2, chapter 4. Okay, have you done tutorial for class?
Yes, ma'am.
42 students. Okay, so we go to tutorial 4. I have uploaded. Okay, actually I have edited some here and there in chapter 4 notes, but I have uploaded the latest version in Microsoft Teams. If I'm not mistaken, I have uploaded this tutorial for solution in Microsoft Teams. Okay, so we have discussed until number 4. Last time we stopped at number
4.
Okay, so this is number 5. Given the household of 120 VRMS 50 Hz, if the voltage If the voltage to the CRT in which the volt per division node is set to 50 volt per division, how many division of the vertical deflection will you expect from the peak to peak? If the time per division of the CRT is set to 10 millisecond per division, how many cycles will you expect to see on the screen if it has 8 divisions vertically and 10 divisions horizontally? So the question is to how many division on the vertical? And okay, if the CRT is 10 millisecond, how many cycle on the screen? Okay, how many division on the vertical? Vertical meaning that the voltage. Okay, so how many division? How many boxes in on vertical? We know that the V is equal to 1 to O VRMS, so you have to convert it to peak or peak to peak. So let's find peak to peak. V peak to peak is equal to surd to V RMS. Because of peak to peak, so we multiply with 2 and we get this 339.41 volts. Okay, this is the value or the magnitude of the voltage for peak to peak voltage. Okay, but this question is find how many division on the screen for vertical deflection. So the number of division is equal to the value of voltage divided with the setting 50 volt per division. Okay, because previously we know that the magnitude is equal to the number of division or the number of box multiply with the volt per division setting, right? Okay, so to find how many division, we should take the voltage divided with the setting 50 volt per division and we get 6.7 divisions or about 7 divisions. Okay, any questions so far?
No, doctor.
Okay, and
Set tu macam mana dapat?
Satu is formula.
100.
Satu
Satu.
is based on formula.
Ha? Mana?
Set tu macam mana dapat?
Set 2.
Set dua.
Kedua.
It's based on formula.
Formula lah. Apa dah? Formula V peak is equal to surd to V RMS, right? Lupa ke? V peak value is equal to surd to V RMS. This is the formula. Okay. So if you want to find the V peak to peak, so just multiply with 2. Okay. So there are 6 division from the highest to the bottom. Okay, for overall sine wave of the signal. Okay, from peak to peak there are 7 divisions. Okay, the next question is, okay, any other question? No. If the time per division of the CRT is set to 10 millisecond per division, how many cycles we expect? Okay. If there are 8 divisions vertically, 10 divisions horizontally. Okay. So with signal 50 Hz, we can find the period. Okay, T is equal to 1/f. So the period for full cycle is equal to 20 millisecond. Okay. And we know that to calculate period, okay, so period is equal to number of divisions or number of box multiplied with time per division setting. So to find the number of divisions or number of box, we take the period and divide with time per division setting. So the period is 20 millisecond divided with 10 millisecond per division. So we get 2 division. Okay, so there are 2 division for one cycle. There are 2 divisions. So how if 10 division, meaning that 10 divided with 2 division for one cycle, so we'll get 5 cycles. Okay, so this screen show 5 divisions. Okay, so we will have 5 cycles of the sine wave. Okay, 5 cycle, 1, 2, and 5 cycle. Any question?
Down there, no.
Can you imagine 5 cycle? Can you draw? Can you sketch on your piece of paper that 5 cycles?
5 cycles and yes.
Yes. Okay. Please, someone share your screen or sketch this signal on a piece of paper and upload your answer here. Someone want to try? Upload your answer at the chat box.
He's trying.
Please try. But please put the label of the signal. Okay. So the V peak is equal to 339. So what is the value of V peak? And then how many division from origin to the peak? How many division at vertical? How many division for one cycle at horizontal? And how many cycle appear on the screen, display on the screen? Someone want to share his or her screen or want to share your answer here? Okay, try to sketch what will be displayed on the screen. Anyone want to try? Oh, I just got a name. Before I call any name, please volunteer, someone to volunteer. Philip nak cuba?
Doing it.
Sorry?
He's doing it still.
Apa dia?
We're still trying to draw.
Tak dengar lah, Philip.
Still trying to draw the sketch.
This is the value of V peak to peak. Okay, so let's find V peak. And then the division on the vertical is about 7. Okay, so you can put 3.5 and 3.5. And then please label the period 20 millisecond. Make sure 2 division for a cycle, and there are 5 cycles. Rabia to Adabia, want to try?
Masih lukis lagi.
Just sketch, okay? Sketch. When you sketch, okay, so make sure you put the label. Sareh? Sare, want to try?
Tengah buat tu. Sekejap.
Okay. Mushfiqur Rahman?
Hello, ma'am.
Want to try? Share your answer?
Can you share whiteboard?
Share whiteboard. Share whiteboard. How to share the whiteboard? Macam mana? Saya tak pernah guna. So I should find whiteboard here outside the Microsoft Team or in Microsoft Team? Bagus lah share whiteboard.
In Microsoft Team.
Yeah. So I kena ni kot
Stop share content dulu.
Okay. Lepas tu find the whiteboard here. Huh?
Itu
Oh
bukan
ni whiteboard. Okay. This one is whiteboard. Okay. Sekejap So I have to stop sharing. Yeah. Tak payahlah. Okay, sini. Okay, save. Creating your whiteboard. Collaborate on whiteboard. Collaborate Everyone can edit. Okay. And then now, I should stop my sharing. Ya ke? Huh? Okay. So, now try to sketch on this whiteboard. Oh, I need to stop my sharing first. I think you just share your macam mana ni? Stop
Yang terlampau kecil ni sikit.
No, that.
So I have to stop my sharing first and then you can proceed to draw on the whiteboard ke? Okay, now who is sketching on whiteboard? Who is sketching on the whiteboard? How do I know the person sketch on the whiteboard? Siapa sekarang ni? Okay, now who is sketching on the whiteboard?
Doktor. Patutnya dekat share content tu kan. Nanti kalau doktor dah share tekan share content, lepas tu nanti dia tunjuk whiteboard ke atau apa. So nanti macam doktor tekan share content dulu. Lepas tu ada nampak whiteboard tak?
Okay, kat situ sekarang ni tekan tapi
tekan whiteboard tu. Microsoft Whiteboard.
Okay, begini. Collaborate.
Pandailah Ramona ni.
Okay, tadi someone has sketch on the whiteboard. Habis tu sekarang ni dah tak ada. Okay. Ni siapa? Who are sketching now? Okay. Ini ada dua orang lah tengah sketching Who are sketching?
I'm the one on the right.
Ma'am, I'm also sketching.
Sorry, Mushfiqur Rahman?
Yes, ma'am.
Okay. M is for Mushfiqur Rahman. Okay. Yeah, sorry. Okay. Okay, class. For the time being, Philip has submitted or share with us his answer, his catch. Okay, so can you see it now? So I need to share my screen. Okay, so let me share my screen. Okay, so this is Philip answers. Okay, so 339 divided with 2, you get 169.7, right? Okay, so this is the peak value, and then one cycle is 20 milli, so meaning that from here to here, or from here to here is 20 millisecond, and then okay, so you should sketch the number of division on vertical, so that okay, there are 7 division on vertical. Okay, just put 1, okay, 1, 2, 3, 3.5 at positive and 3.5 at negative, like this. Okay, and then you should, okay, so now we have 1, 2, 3 only. Okay, but you should add another 2 cycles. Okay, because there are 5 cycles display on the screen. Okay, understand or not?
Okay, I understand. I thought period and cycles are different.
Okay, so please add another 2 cycles. Okay, and please show there are 7 divisions on vertical axis and 2 division for each cycle. Okay, so we go to the next question, number 6. Determine the voltage peak to peak, frequency, and phase difference between the 2 waveforms. Okay, so for A, this is A. The peak to peak is 1, 2, 3, 4, 5, and 6. Okay, so 6 multiply with the volt per division. This is volt per division. So it is 200 millivolt. So multiply with 200 millivolt, we get 1.2. This is for A. Frequency for A is, okay, count from here to complete a cycle. So we have 1, 2, 3, 4, 5, and 6. Okay, 6 division in a cycle. Multiply with the time per division setting. It is 0.1 microsecond. Okay, 0.1 millisecond. Sorry, millisecond. This is millisecond. This is micro. Okay, so this is the period. Frequency is equal to 1/t. So we get 16.7 hertz. Okay. How about B? A and B must have same frequency. Okay, because we want to compare the phase difference, so frequency A and B must be the same. Okay, or you want to confirm it, so for B from here to here, 1, 2, 3, 4, 5, 6 division. Okay, and using the same time per division setting, we will get the same frequency for B. For B, the voltage is Okay, about 1.2. Okay, multiply with 2, you get 2.4. Okay, multiply with the time volt per division, 200 millivolt, and we will get 480 millivolts on B. Okay, and then how about the phase difference? How to calculate the phase difference? Okay, count how many box or how many division of A and B, the difference, okay, the phase difference. So only one division, so 1 over total number of division on horizontal axis for one cycle, it is 6 division, multiply with 360, we get 60 degrees. So A and B differ by 60 degree. Okay, or phase difference is okay, since there is one division, okay, so 6 division is equal to 360, 1 division is equal to 360 divided with 6, we get 60 degree. Any question? Sarah, okay?
Clear, doctor.
Okay.
Basam, okay? Okay, this is number 7. The waveform of a typical electrocardiogram ECG signal display on an oscilloscope is shown in figure 7. If the vertical sensitivity is set at 100 millivolt per cm and the sweep speed is set at 2 milliseconds per cm, this is vertical setting. This is for horizontal setting. Find the peak-to-peak amplitude Vp on the signal and the frequency that represents the heart rate of the person to whom the electrodes are attached. Okay, peak to peak. Okay, so just count how many divisions on vertical axis from peak to peak. Okay, so there are about 2.5. Okay, 2.5 multiply with 100 milli. Okay, we get 0.25 volt. So this is V peak to peak. And then frequency is equal to 1 over T. So for a complete one cycle, we can take from this peak to this peak. Okay. Or from here, from the starting to this starting. Okay. Will be the same. Or from this peak to this, okay, or from this to this, okay. So it is about 1, 2, 3, 4, 5, 6, 7. Okay, 7 multiplied with time per division setting, it is 2 milli. Multiply with 2 milli, so this is period. How to find frequency? 1 over period. So 71.42 Hz. Any question? No. This is Lissajous pattern. Find the frequency of the vertical plates if the frequency applied to the horizontal is 60 Hz. So we should write the equation for the ratio of frequency first. How many loops on vertical? 1 only, right? 1. Only 1. Okay, only 1. So 1 FV is equal to how many loops on horizontal? 1, 2, 3, 4. 4 equal to 4 FH. So FH is given 60. Just multiply with 4. We get to 40 Hz. Any question? Any?
No, doctor.
No.
Okay, this is I think the last. No, number 9. The trace of 2 signals on the screen of the CRO is an ellipse. Okay. The slope of the major axis is negative, meaning that like this, negative slope. The maximum value is 3 divisions. Okay, meaning that this one 3 division. And the point where the ellipse crosses the vertical is 2.6, meaning that here. The ellipse is symmetrical about horizontal and vertical axis. Okay, horizontal. Symmetrical. Determine the phase angle between the two signals. So we know that this is the formula. So sin theta is equal to 2.6. Okay, the intercept divided with the maximum value on the vertical deflection. It is 3. Okay, equal to equal to some number. Okay, and then theta is equal to 60.07. Okay. Theta is equal to, jadi macam ni pula. Sudah. Am I right? Kan juga ni. Okay, class, I think you can understand. Okay, later I will edit. Okay, the last. This is the last. CR is set to the XY mode if both input signal are sine wave on the same frequency and amplitude with 90-degree phase difference. Draw the output display that should be obtained. Okay, so we know that 90-degree phase shift. Lissajous pattern will be a circle. Okay. Same frequency and amplitude. So okay, so it will be like this. Same frequency. Okay. Frequency on horizontal is equal to frequency of vertical. So we will get circle, a circle. Okay. Any question, class? Can I understand? Any question on chapter 4? Any question?
So far, no.
Okay, so can you compare which chapter from chapter 1 until chapter 4? Which one? Which chapter is the easiest and the most difficult? Haris, nak cakap?
Chapter 1 easiest.